Hello guys, in this lab we will discuss the use of subroutines and stack manipulation to assist us solving series and parallel DC circuits. By mathematical standards, the x86 microprocessor is relatively primitive, but if the programmer knows how to exploit the hardware, it can tackle some interesting issues. Finding the overall resistance of a resistive circuit is one practical issue. So let's go ahead and show you guys what are we talking about here. We're going to start with this circuit you guys see right here, and we're going to write the code for the total resistance of this circuit up here. Okay? All right. Now, you probably have learned from previous classes to find the total resistance of a given circuit and parallel, you use this formula right here. Okay? All right. This formula right here. Now, of course, again, from previous classes, you see some algebra. We can manipulate it, like so, if you have two resistors. Now, let's go down here, because our circuit, as you guys can see, we have resistor 3 and resistor 2. They're in series with parallel with resistor 1. So right here, using again algebra like we did here and here, we came out with this. Okay, now just be aware there's some typos here, unfortunately, but it's okay. Let me show you here before we go. This is supposed to be 3 and 3, and this is supposed to be R1. Okay, because R3 and R2 are adding. They're in series, so they're adding. So they're right here adding. And R1 is the one parallel. Okay? Just be sure you guys do this part. It's really important. Okay? Now, going to the code now. As you guys can see, there's nothing much going on here. We're just using what we have learned before with subroutines and stack manipulation to create this program. So let's go ahead to the coding, okay? All right. Let me go and close here. I'll minimize here for now. Let me open up my Visual Studios. All right, guys, now that I have my Visual Studios open, let's go ahead and click Create New Project. And before we continue on, please don't forget to like my video, comment below, share it, and subscribe. Don't forget to read the description below for more information about the video, the timestamp, and how to support me. Okay? Thank you. Now that we have clicked there, we're going to go ahead and go to our template. Again, you can type up here as long as you have everything, all language, all platform, and all projects type. Just type in here x86 and it'll pop up. We'll set it here, click next. This is lab number 9. Oops, sorry, I meant lab number 8. So we'll do lab 8, program 1. Okay, leave this unchecked. Keep this your default location, whichever you had the other programs in. Again, try to keep the name short and try to avoid spaces so you won't have any problems. Hit create. click over here, double click. All right, so now with the help of editing, here's our code. Again, do not copy and paste it, type it down because of the syntax. It will give you some errors. So let's go ahead and run this so I can explain to you what's going on. And first thing, we change this to 86. We go to build solution. Okay. Also, be sure your program is safe, just in case something happens. Okay. We're gonna do debug. Start debugging. Oh, I forgot. You probably noticed that I forgot the breaker. Let me stop that. Let's try it again. Put a breaker right here in the beginning. Okay. All right. Let's try it again. Debug. Start debugging. Okay. Be sure I have my. Oops. Let me take this. I have my wash window out from the previous video. Remember to get this window to help us translate from hexadecimal to binary now. I'm sorry, from hexadecimal to decimal. We went to, let's see, sorry, debug Windows, and here it says watch 1, and that's when we get this. Here I'm going to type in my registers. We're starting order, EAX. Move my mouse so you guys can see. EBX, enter. ECX, enter. EDX, enter. Okay. I will also need my flags, so I'll right click. Here's my flags, so we can see what's going on here. Okay. I'm not going to explain every detail. I'm just going to give you an overall summary of what's going on. Please, in your report, I recommend for you guys to go ahead and mention something about the flags, what's going on there, if possible. And let's go and let me put this guy. Actually, all right, good. Yeah, I want it there. Okay, register here. So watch, just move it there. Okay. All right. So let's see. So remember, from what we're trying to do here, let's go back to the drawing. We have 3 resistors. We're going to add resistor 3 and 2 together using the series formula, which is this one right here. Just add them up. And then once we get the total, we're going to do the adding the resistor 1 with the total resistor 3 and 2 using the parallel formula, which is this one up here or this one right here. And of course, there's all of them together. So there's the formula we'll be using in a way. Okay. All right. We're going to be using, back to the code, our numbers are 100, 400, and 600. And let me just double check if I wrote this down right. Let's see what it says here. Okay. Let R1 be 100, R2 be 400, R3 be 600. Okay. All right. Hint, since we're using multiplication division instructions, remember they act on the values in the EAX register. Yes, EAX, we use them for multiplication division. And the others will not work. Okay, back to the code. All right, let's see. First, we're going to be moving what we declare here, R2, which is 400, to AX. And then we're going to add R3, which is 600, to AX. Since they're in series, we can add them up. All right. So let's go to first step here. Notice everything's on 0. That's because of this little guy here. All right. We move R2 to EAX. Now you probably have said like, what's going on? I mentioned this before, but just in case, what's going on here? I thought 4 is supposed to be 400 for R2, yes, but we have a 190. Well, 190 and hexadecimal. However, if you go here, 400 and decimal. Okay? Alright, let's continue on. Then we do R3 added to AX. That means that 600 got added to the 400 that was in AX. So 600 plus 400 equals the 10,000. Oh, what's it? 1,000. Yeah, 1,000. So let's go here. Watch. There goes 1,000 and decimal. Okay. Okay. Continue on. Next step is moving whatever is at AX to BX. That means we did the addition, the math, the arithmetic here, and then we're going to move that number here to keep it placed there. So let's go and click that. So that number can move here. All right. Next step is going to be add R1 to BX. There it goes. So now, so it was 1,000, remember, but R1 is 100. So we added. Here you go. That's 1,100. Okay. Go back to register. Next step is going to be multiplying R1, the sum of R2 and 3 by R1. So we're going to multiply what just happened, what is in here, and we're going to multiply whatever's in here with R1. Remember, if you want to do any multiplication or divisions commands, the command will look at the register AX. So I was going to say here, okay, here again. So you see how it says divide? It's going to divide whatever's an AX with BX, okay? All right. So this let's see, I'm sorry, lost my place. It's dot here. Okay. Multiply R1. Okay. So EAX got changed because there was a multiplication with R1. R1 was again 100. Before it was 1,000. Let's see what happened. So it got multiplied. And this big number came out. Okay. And notice that in red are the numbers that have changed previously. Oh, I'm sorry, recently have been changed. All right. Let's continue on. Let's see, where are we? Okay. Here we're going to do a division. We're going to divide the numerator, AX, this number, this value, by the denominator, which is BX, this value right here. Let's see here what they are. Let's see, this is going to be this value divided by this value. Okay. Okay. Pretty much we're doing this. We are pretty much at the end here. We already have this total right here, and we already have this total down in the bottom. We're just doing the division now. Okay. Okay. All right. See. And there it goes. Okay. So our final answer is 90. I'm sorry. We have to look at this first. Our final answer is 5A, which means 90. Okay. And of course, if you do this by hand, it should give you also 90. I do recommend for you guys to do this by hand first. Okay. First do this by hand, and then go ahead and do the operations here. Okay. Okay, now let's go ahead to program number 2. Let's talk about that a little bit. In program number 2, we're going to go ahead and use subroutines to separate the series resistors and the parallel resistors. So let me show you down here. So once R2 and R3 move to the registers, we're going to go ahead and call the series subroutine, which is down here. And now, because they're in series, we just add them up, as you guys can see here. And then it ends the series subroutine, and it goes continue on right here. And then we end up moving register, move the value of R1 to register BX. And then we're going to call the parallel subroutine. And then we're going to do the parallel operation for the parallel resistor. And that's pretty much for the second program. On the third program, we're going to do using subroutines and the stack. Please be sure you guys read the instructions. I'm just going to give you guys a quick preview of program 2 and program 3. So, but please read them. Says the stack. If you have ever paid close attention to the architecture of the x86 microprocessor, you will find there are two registers called SS and SP, the stack segment and the stack pointer. The concept of the stack is not unique to the x86 machines. In fact, many computers have begun to incorporate a designed stack engine to manage the stack. The 86 stack operates on a last in, first out basis. Think of the stack like a bunch of diner tape plates or building blocks. Okay, so last in, first out. So the last one who came in, last in. So the number. So if you stack values, and T7 is the last one who comes in, and you want to take it out, it'll be the first one coming out. If you want to take out T1 first, you have to take out T7 all the way through T2 to be able to take out T1. Okay? And we use the push and the pop instructions to help us with that. Okay? Push is when you put the value of or the AX into the stack, and then pop is when you want to take it out or pop it out. Okay? Alright. Well, good luck guys. Please do not forget to like my video, subscribe, comment below, and please read the description below, okay? Alright, thank you. Goodbye.